Good computers steal bad hackers.
I am also recording the thing. Welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 234. We'll be talking machines on fire, old Kinect, new Kinect, and birth of the breadboard. This week in the news, Polish railways fall victim to cheap radio attack. This is pretty fun. It got covered in some news media as a cyber attack, but actually there's a particular analog radio signal at 150 megahertz that sends the stop command, the radio stop command to Polish railways. Somebody probably with Russian sympathies was playing the radio stop command and shut down 20 trains all at once, which is, of course, mayhem.
You know, I did think it was interesting, like, in the write-up, Lewin does start with that, like, it's not a cyber attack. And yeah. I don't know, I suppose the literal definition of a cyber attack must involve a computer, right? But I'm pretty sure they didn't do this with, like, a spark gap, right? So there probably was a computer involved somewhere. I would bet, like, a software-defined radio was used, although I suppose it's possible somebody had, like, a snuck in a old ham radio.
It sounds like it's not even necessary. It sounds like it's a simple signal at a given frequency. But whatevs.
I can see why someone thought this was a good idea at the time. And apparently in the comments they said that this was like implemented in response to some rail accident from back in the day. And they realized, oh, we need a way to be able to stop the trains really quickly. So, I mean, I get it. But as the ability of the average troublemaker is increasing, I think you have to keep up with the times, right? And include some kind of, I don't know. I guess the argument is any kind of authentication you'd put in there would delay it, right? You know, you want it to happen as fast as possible. So if it's got to do some weird handshake, and by that time the train is, gone off the rails or whatever. So I see it from both ways.
The comments go through this pretty well, but there are all sorts of systems like this everywhere, like the way you can flash lights if you're an ambulance to get through red lights in the States. And, there's all these systems that are not secure and are abusable, but you'd really have to be a jerk to abuse it. And I think we kind of live on that world where we rely in a lot of ways on other people not being a jerk. And I don't know that that's really a problem.
Yeah.
Until there's
an incredible amount of stuff that we just count on like common human decency to keep from happening.
Yeah.
Right. Yeah. So I suppose this could be one of those cases. And then somebody had talked about like they were looking at replacing it with some kind of digital cellular deal.
Yeah.
But in that case, it said like if it loses the signal, the train would stop as a failsafe. So then somebody in the comments is like, okay, well then you could just jam the digital signal. Like so, there's always going to be some way to harass any kind of system in place. It's just a matter of the desire and the technical know-how.
I also like that someone says that this happens something like 500 times a year.
Just nobody talks about it.
And that and everybody knows it can happen. And this is just the one time that some probably coordinated bunch of jerks stopped 20 trains at once instead of just one at a time. And in totally not news, I was looking through Hackaday and stumbled on an old article from 2022 that I hadn't seen in a while. Add full color images to your 3D prints with toner transfer. And this is the one where you do laser printing, color or otherwise, on like transparency film or basically anything. And then you use that as you tape that down to your 3D printer bed and then print on top of it. And then your 3D print gets that, whatever it was you printed embedded in it. That's just so rad. Why haven't we done this? Have you ever done this, Tom?
No, but I mean, the end result looks phenomenal.
So good.
In the picture. Yeah.
It's so rad. And this just reminded me randomly today that if you go through old Hackaday posts, you find things that you at the time were like, oh, dude, that's the coolest thing I've ever seen. I absolutely need to do that.
And then move on to something else.
And have you done it? No.
No. The next thing that glitters, like, ooh, look at that.
Exactly. So go back through Hackaday and pick one. This is my Hackaday challenge to our listeners, is to go back through, say the last 20 years of Hackaday and pick one of these projects that you've always wanted to do and, just do it this weekend. Just do it.
I like that we're not considering September of 2022 an old post. I thought this
Wow.
might be a little farther from the archives, but it's funny when you put the link in there. I also remember seeing this and being like, oh yeah, I definitely gotta do that.
It's so smart.
And it seems very straightforward. Of course, devil's in the details. I'm sure it's not as straightforward as it looks, but like control panels to me have always been like that. Like it's always so hard to nail down. And even with the incredible array of modern stuff that we have as hackers and makers, it's still kind of tough to make a professional looking control panel. I mean, you could, print something out on your inkjet printer and do like a transparency, but it always kind of And it's kind of funny that we've come so far in so many other ways, and this is still like that. Ironically, the first thing people see on your project is still the one that we kind of struggle with.
And last breaking news, we had a fire in the Hackaday coffee roastery today. And this is a cautionary tale. It's always the software. So I have a coffee roaster I built myself. It uses a heat gun and some other parts cobbled together to roast coffee beans. So it pushes hot air and turns the heat on. And it's, it can control both the fan and the heat independently, and it's got a temperature thing. And one of the things I implemented was a safety mechanism where if it doesn't see it heating up to a certain temperature within a certain amount of time, turns the heater off and runs the fan on full, assuming that something's gone wrong or I forgot to put the temperature probe in again or something like that. And it's been falsing recently. I don't know why. It's just different temperatures or something. And so I went in to tweak those values, and I'm like, those should be variables. So I put them in EEPROM so I could change them on the fly later. Reflash the thing, and then I run it. I do kind of notice that the heat's all the way up on full. And I'm like, there's no problem. And then I watch the temperature rising just ridiculously dramatically. And I'm like, uh-oh, that's a problem. So I put it in emergency cool down mode, which again turns the heater off and runs the fan on full. And it keeps getting hotter. And I'm like, uh-oh. And then I hear this noise that sounds like a small jet engine in the bathroom where I'm roasting this. And I'm like, uh-oh. So I run in there, and there's a, no joke, 9-inch plume of fire coming out of the top of the coffee roaster. The aluminum output tube that, takes the chaff and stuff and pitches it out the window is completely melted. When you have a fire and you feed it lots of oxygen by keeping the fan running, it turns out you've made one of those forge things with charcoal coffee and a forge, and everything is horrible. And so I'm like, panic, unplug. And, I ran back to get some tongs and something I could hold the thing with. And I pitched the on fire coffee grounds into the toilet, and it's just an absolute nightmare. And my wife is like, what just happened? Doo, doo, doo.
Listening to you describe the situation, it struck me how, eerily similar it was like to Chernobyl or something like
Thank you.
Like the numbers were going up and they're like, oh man, we're in a bad state, hit the emergency shutdown, and it only got worse, right? Because unbeknownst to you, the emergency shutdown caused the situation to make it worse.
And the emergency shutdown always worked in the past. And this time, of course, if things aren't literally on fire, it cools them down. But when they are literally on fire, and this is the first time that's ever happened to me in 20 years of roasting coffee. Whew. Anyway, so long story short, I come back to my logs and I'm like, what the hell's gone wrong here? And I'm looking, and it's like set temperature 2047 degrees.
And that
it's 2047 Celsius, so it's even hotter than you think.
Boy, yeah.
But that's why it went full on. And the answer is that when you reflash the code but don't reflash the EEPROM, everything is shifted over by a little bit. And it was expecting the temperature variable to be, in memory, in these 2 bytes of memory. And it was in adjacent bytes or who knows where. And it just got some arbitrarily horrible high temperature out. And so... Memo to self, reflash your EEPROM every time you reflash the chip.
And that is how an RBMK reactor explodes.
Yeah, so I changed my make file so that it flashes the EEPROM every time, which means I lose my custom settings if I've made them, but at least I don't get a fire in the bathroom. So embarrassing. Everything's fine. It smells like a campfire in there, basically. But other than that, everything's okay. I have to rebuild it later tonight after the podcast so that we have coffee for tomorrow morning. But other than that, non-disaster. Temperature probe held up. Fortunately, nothing caught on fire that matters.
That's always the important part. There was a fire, but nothing important burned.
The wooden window frames that, consist of a part of our house are not on fire. Don't worry, hun. Yeah.
And I almost never burn the same thing twice, too. So, like, once you've learned one time,
right? Exactly.
how not to set it on fire, you probably won't do it again.
It'll never happen again. Oh, God. Shall we move on to What's That Sound?
Sure. Before anything else burns down at your house.
This is a journey into sound. What's that sound?
What's that sound?
This week we've got a sound from FedEx from the Discord. We found a similar sample online somewhere. This one's got a little bit more detail to the recording, so we use this one. But thanks, FedEx, for the inspiration.
When you finish up any of the labs, you left off on lab 5, 317.
No, I say we know what it is. We can't do the normal guessing game, but
Both Dom and I know what it is, so
yeah,
that's out. But if you know what it is, head on over to hackaday.com/podcast. Find the form, fill it in with your best guess, and next week we will pick among the correct winners. Somebody's going to get a Hackaday podcast t-shirt.
So now who goes next? Who has to guess what this is?
Oh, yeah, good.
Al's gonna get it.
You think, you think
Al
so?
Al probably has one.
Yeah, that's probably true.
He's like, oh yeah. I worked on these
in my garage.
Yeah, you need one? I got an extra one.
Exactly. All right, well, my first hack this week is impulse buying a 3040 CNC machine. What could go wrong? This is actually a great set of videos by Joe Kutz, and it's the story of him finding a cheap Chinese CNC machine that looked basically unused on kind of Germany's equivalent of Craigslist. By the way, what is Germany's equivalent of Craigslist? I don't even know. Shoot me the answer in the comments, because I'm desperate for a Craigslist. Anyway, he says it's Germany's equivalent of Craigslist. This is a hilarious series of videos. I think there's 5 of them now. And the answer, of course, to what could go wrong is everything. Parts of it were bent. He's basically rebuilding this whole CNC machine, which I think is really interesting. I'm actually really excited for the next video in the series, which is going to be where he digs into what's inside the controller box, because the firmware/software that comes with these things is usually entirely horrible. It's usually like pirated software and ill-described hardware. And I actually have a 6040, the bigger version of a similar machine to this, and I had to replace all that stuff. Instead of using like a parallel port, I did exactly what he did, which is I ran Gerbil on an Arduino, and it's served me well for the past 5 years, so you could do worse. But I think it's really neat to see him kind of taking apart and upgrading this cheap machine, because, even if you don't find a scratch and dent one, they're dirt cheap on eBay, and it is a tempting pickup.
These are projects when you buy them, and they're very tempting. Like you said, they're cheap. I mean, sometimes I go on Amazon and kind of browse through them, and it's like, man, like you'd think just the frame would cost more than some of these things are going for, but when you buy them, like, you're taking on a project, like, no question. It reminds me a lot of the early 3D printer days.
Yeah,
and the same thing kind of with the, like, you buy a K40, like you just assume there's going to be several $100s more components purchased and installation, and that's kind of the deal, right? But in the end, you have a tool that be far more expensive if you bought it turnkey. So
totally. I need to write mine up, actually. My experience was that I had to kind of reverse engineer the controller so that I could get it working with Arduino and Gerbil. And then all the motors were badly spec'd. They wouldn't run fast enough. They were
Of course.
the steppers were all configured for maximum torque, where they really don't need it because this thing has beefy ball screws. Instead, it needed more speed, so I had to buy 3 new stepper motors to drive the X, Y, and Z on it. What else did I have to do? Oh, add limit switches. I mean, there's all this work you have to do probably if you buy one of these. And I at least got a good motor and spindle on mine, so I had to do a lot less work than he did. That all said, a lot of Joe's problem was bent parts, which makes me think that this one got dropped in shipping or something. And like the parts of the Y carriage were warped and parts of the rods were warped. And actually, that's one of the really cool parts of the video is him kind of straightening these things out jigs, making an unbending jig, basically. And then his realization that where one of the Y smooth rods was bent and the other one wasn't, he could actually use that to his advantage because the thing sags enough under its own weight that he probably wanted the bent one to remain bent. And so he actually bends the other one up by, 0.08 millimeters so that when the heavy carriage is sitting on it in the middle, it actually deflects it down and it runs basically flat. I thought it was pretty funny to even just the idea to bend the smooth rods in the opposite direction to counteract gravity. I do not know if that's the right thing to do. It gives me a machinist willies, but it scares me. But on the other hand, when you're dealing with one of these machines, anything you can do to make it run better.
Is there anything like a picture of something that's made with it, or are we not at that phase? He's still
We're not at that phase. Yeah.
It's still not even like fully functional, right?
He starts off, I think, even his 4th video with, here's a pile of parts under my desk. So, that will eventually become a CNC machine again.
All right. Well, the first one I wanted to talk about this week is something that kind of near and dear to me. This is the latest update on the Arecibo Telescope and collapse thereof. We wrote quite a few articles on this. It was kind of a unique situation in that we got to follow it along kind of in real time because it was clear there was a problem, and then the problem got worse, and then it seemed less likely the problem would get better, and then one day, crack of dawn, it just collapsed on itself. And I think we have articles for like every phase of that situation, but now we have 3-ish years later, we're starting to see the final kind of reports on what happened. And it was obvious just watching the video that the cables had gave way, and I think you needed 5 of them and like 3 of them failed or something. But why the cables failed, right, was the question. Some people thought maybe it was the environment. It's obviously a lot of humidity and that kind of stuff, and I think they have earthquakes and that kind of deal. They used neutron imaging to look at the cable ends and found that basically they had started slipping, and they slipped and slipped until they pulled out entirely. And the interesting was they can't tell exactly how long it had been going on for. Like it says in the report, like maybe that this is from the last 48 hours or whatever, or it could have been over years. They can't really tell that at this point. All they can say is that the cables had been slipping out from when they were manufactured. It kind of goes into the engineering of it and why they made the decision to do it that way. Basically they put the cables into the socket and then poured molten zinc in there, and that solidified around it. But over time, the zinc and the cable, that interface started to slip. And I mean, it worked from the 60s, right? So it's not like it failed overnight. So you gotta give it credit where credit's due. It doesn't bring the telescope back, which is a shame. It's nice to know what happened, and certainly lessons will be learned. But it's kind of a bittersweet, I guess, end to the story, because I think we're pretty much at the end now. I mean, they're already cleaning it up, and now they know for sure that the cable slipped out, and it wasn't anything nefarious going on or anything like that. It was just a decision made in the 60s that 50 odd years later maybe turned out to be questionable. Right. I guess the argument is if they had known this was happening, they could have changed the cables ahead of time, maybe, but there was already a lot of talk about the maintenance was kind of questionable for the last decade at least, and there was storm damage. I remember when we wrote about this before, there was like storm damage that was like over a decade old that they still hadn't fixed, let alone do preventative maintenance on changing the cables. So I mean, it was kind of doomed, I suppose, unfortunately. But you know, it's still good to like find out why this happened, and the technology that was used to figure it out is very interesting too.
The comments are, you know, full of both sides of this. They're like, oh, that's shoddy workmanship. And then the other people are like, are you kidding? It's held up a 900-ton instrument for 60 years. How are you calling shoddy on that, right? In Puerto Rico with hurricanes and earthquakes and, you know, serious weather and, right? I'm not a civil engineer, but I kind of have to fall down on the, wow, that's pretty impressive side of things rather than the, you know, oh boy, they built that crappy. I'm not 60 years old and I'm not holding anything up that's 900 tons. So, you know, I'm not going to cast the first stone here.
And then, like we always say, you know, some of the best stuff is in the comments. And then you had people saying, you know, oh, well, they should have welded them. You know, why didn't they weld the cables and that kind of thing? And there's a whole breakdown that says, well, if you weld the cable, you actually weaken it. And the way this works, this preserves the strength of the cable. And somebody gave a really good description that they said, you know, if you imagine like pushing the cable through the small end of a funnel,
right,
and then splaying it out on the other side of the funnel, and then pouring molten whatever into the open end of the funnel, you know, that's what they basically did. So like the cable went into a little thing, splayed out, and then they poured this, you know, you pour this thing around it to kind of make a block, and it can't go back through the funnel, well, unless it slips over 60 years. And but you don't compromise the material itself. So I mean, it's sound engineering, and it worked, like I said, for a long time in terrible conditions. But like anything else, it probably should have been looked at more frequently, and there should have been some kind of plan for placing the cables every, I don't know, half a century or whatever. It's all hindsight 2020 kind of stuff.
My next hack, going to extremes to block YouTube ads, is kind of a hacky hack by Eric. This is actually crazy. If this post is way too long and in way too much detail. It comes from January 6, 2022, and I wouldn't be surprised if some people are still reading it. The short version is that he wants to make something like a pie hole except using pfSense, and the idea is to block ads served to him by YouTube. And you would be surprised how hard it is to do that. He tries everything. Anyway, the first few pages worth of detail in this write-up are about how to set up the pfSense network and do the whole firewalling, and it's actually extremely interesting. And then he starts digging into how YouTube sends you ads. And he tries a whole bunch of tricks, like pretending he's VPNing in from a country that YouTube isn't interested in sending ads to. But it turns out there's an ASN leak in the VPN node he's got. And YouTube is actually looking for this. And so they figure out that he's actually in the UK and not in Italy like he's pretending to be. He finally does find a better VPN and get around this. But then the question is, how do you get the ads out of YouTube? And everything is HTTPS encrypted, so he has to install MITM proxy on his computer. And so he's man-in-the-middling Google to try to decrypt their data so that he can figure out where they send the ad data and tell them not to do it, right? And that's really awesome. And then when he finally gets to the data, it's also in Google's protobufs format. And so he kind of has to decrypt that. And doing that on the fly turns out to be hard. And it's, especially in Python, it's the protobufs library he's using is just too slow to do it in real time. So he doesn't end up getting complete success with that, but he also ends up, because he's man-in-the-middling it, he can send bad data back to Google. And in the very, very, very end, he figures out that he can change one byte in the protobuf message to say, I'm using a schema that you haven't implemented yet to Google, and YouTube doesn't know what to do with it and doesn't respond by playing an ad, and voila, victory. But what? This is the craziest thing. And then, of course, because he feels bad about depriving people of their ad revenue, he then subscribes to YouTube Premium, But then B, because he knows how to forge these protobuf messages, he can now also set up another computer that he's just not watching, that's just playing YouTube ads all the time. And so he's also kind of, as a side effect here, invented a way to make an ad watching bot. What?
This is a great reminder that the difference between brilliance and madness is really it's a blurry line.
Yeah.
Because like I don't think anyone listening can imagine how long this write-up is. Whatever you think, like however long you think it is, it's like at least 3 times longer than that. Like
it's full of goodness too. Like, don't get me wrong, it's full of 10 interesting things.
Yeah, it's fascinating stuff. But I mean, I don't know the last time I saw such a long and detailed write-up, which I'm certainly not complaining about, right? Like that's kind of
thank you,
our thing, right?
Yeah.
Like that's kind of what we're here for. But to go through all of that, I mean, it's to talk about dedicated to the cause, and then like you said, the in the end it's like, I'm gonna get YouTube Premium. I've been working on this for months and months, and I've written this incredible documentation, and I'm patching binaries and stuff. But you know what? I'm just gonna give YouTube that money, But even that, is not the normal, right? He's not just doing YouTube Premium and just watching YouTube like a normal person. He's now talking about running streams constantly to make sure like his favorite creators get their due. So
yep.
Whatever it is, there's always somebody who's really, really into it, And this is the person who's really, really into figuring out YouTube advertisements and how it works. I don't know if there's many people with this particular set of interests and skills, but I'm glad that we found this one at least.
What I think is really interesting about this is both how incredibly determined Eric is, right? Like he is not going to let this one go. But also how incredibly equally determined YouTube is to shove these ads down your throat.
Yeah.
Because they're not even, just serving them to you. They're verifying that you see them. He has to reverse engineer the signals they're sending to him to be able to not watch ads. And like the fact that Google is actually looking for ASN bypasses to figure out if you're trying to tell them you're in a country other than you are, if you're trying to use a VPN to get around it, they really care about figuring your ass out. And they are spending a lot of resources on it. And so, for all of Eric's kind of extreme determination here, and again, I totally appreciate the documentation of it. Like Google/YouTube is easily that bad, is easily that determined on the other side. And so he had to do this.
This is a perfect David versus the Goliath, right? There is no bigger Goliath in ads and snooping in what you're doing than Google. They are they are the top players. So, to go up against them and ultimately come out ahead is very impressive, even if I guess the final answer was that maybe it's not worth the trouble. I mean, at least it can be done, right?
Of course, he could just be saying that to cover his ass. I don't know for sure. That's what I'd say too. No, the other thing that I think is worth noting about this is he learns so much along the way. He learned everything about proto-buffs. He learned everything about man-in-the-middling things. There's just a ton of knowledge gained from him trying to do this. And that reminds me that when you take on a project that you can't do yet, you always end up learning really cool stuff along the way. And I think that's part of one of my takeaways from this write-up anyway, is that he obviously learned so much from it and documented so much of what he learned that it's, it ends up being a tremendous resource kind of over and above the particular hack.
Well, speaking of a determined individual spending a lot of time fighting a digital Goliath, Jenny List wrote up an article called GTA 6 Hacker Found to be Teen with Amazon Fire Stick in Small Town Hotel Room. True story from the media. going back a little bit, there was information leaked about Grand Theft Auto 6, which is a extremely in-demand game that everybody's clamoring for and trying to get these little glimpses at. The information, I think it was screenshots or something, was leaked, and one of the people is a teen. It's an interesting story for us because, hackers leaking information. So that's kind of interesting from a security standpoint, regardless, right? No matter who they are and how it happened. But what was particularly interesting here is that this was apparently done with an Amazon Fire Stick, because he didn't have access to a computer. He's already been denied access to a computer, so he was in a hotel and was able to use the Fire Stick, which is ultimately just a little computer, right? Plugged it into the TV, and it's kind of nebulous. No pun intended. It's nebulous that it says he, access cloud services, which Jenny kind of assumes is some kind of virtual Linux environment. And from there was able to cause this trouble and get into people's systems and that sort of thing. And, this got a lot of comments. Obviously this is a very skilled young man, and it's a shame that, he's not even 18 years old and now looking at jail time for this kind of thing. And maybe the education system failed him and we should be identifying, these kind of the youth that are into this sort of thing and finding more productive outlets for them. And, hey, if the school had been there, maybe things would have been different. And then other people say, oh, it's a victimless crime because, they're going to make billions of dollars on this game regardless.
But let's be clear here. He was ransoming Rockstar Games about this last one. He's like, I have the source code. If you don't contact me within 24 hours, I will start releasing it. So, yeah.
But it also kind of reminds me of when they thought like Mitnick could whistle the launch codes or whatever.
Right.
Like they didn't even want him touching a phone because they were worried like he was such a mastermind that if he got to a phone, he'd be able to whistle code, which was, it in itself, like a, what would you even call it? Like a folk legend based on a kernel of truth because they were whistling, 2600 tones into the phone. So like someone had heard that and we're like, okay, well, if they could do that, if they could whistle and get free phone calls, naturally, they could also launch nuclear weapons, so
right.
This is almost like, that fear becoming a reality. Like, well, okay, we'll take the computer away from him. We'll stick him in a hotel room. It'll be fine. And he's just got his Fire Stick. He's just going to watch Netflix. There's no big deal. It's going to be cool. And then boom.
This one's not a hack. This is Microsoft discontinues Kinect again. And I actually thought this was interesting because I didn't know about the new version of Microsoft's Kinect, the Azure Kinect, which isn't the old school Kinect you might be thinking of. And I'll talk about that for a sec. Anyway, the Azure Kinect is a really expensive device. It was, released as the follow-up to the old school Kinect, but it has awesome hardware on it, like 7 microphones. It's got a super well-aligned camera. It's got IMUs. But the absolute centerpiece here is that instead of doing this kind of structured light thing like the old Kinect did to do depth sensing, this one actually has a time of flight sensor array. It's like a normal camera array, except they're doing time of flight sensing on each of 1 million pixels as it goes across. And so you kind of illuminate the whole scene with infrared. This is infrared light that's modulated at a certain frequency, and it bounces off whatever, and it comes back. And at every pixel, they then correlate the received modulated frequency with the transmitted one and figure out the phase shift, and from that, they can figure out how far away it is. The fact that they're able to do this at, 1 million, and I think they've got a 4 megapixel one as well. Like, it's just an insane sensor in there. And so, yeah, makes sense that this thing costs $400. I'm not at all surprised. If you are like me or just hearing about this sensor now, even if you can't afford it, like me, and are regretting it, don't worry. Microsoft has one of their euphemisms of how they're killing the Kinect project is they announced that they were transferring to partner ecosystems. So they're actually selling off the tech to do these crazy sensors. And the good news is one of them's to analog devices. Analog's going to make these awesome sensors going forward. And a couple other companies are making them packaged into camera-like things. So yeah, Microsoft is out of the game, but other players are picking up the slack. So if you are like a researcher who really needs one of these for your 3D vision robot, don't fret. You can still get it.
I'm struggling to think of another device that has had kind of such an interesting trajectory as the Kinect sensor, right? Because it started as literally Microsoft was like, I need a way to figure out when people are dancing in front of their television.
Right.
And so they came up with this depth camera. And of course, it's at the time it was, going to be packed in with games. So it was an add-on. So it couldn't be very expensive. You can't have like a $500 depth camera for your Xbox, so nobody's going to buy it. So they had to make it cheap and they had to make it easy to use, and they succeeded. And people didn't like it that much, but they were very serious about it. So when the next Xbox came out, they actually made it, for a brief time, it was required. Like, it actually came with the Xbox. And again, people didn't really like it that much, because ultimately when you're playing video games, you probably just want to sit down on the couch and not do so much dancing and exercise. If I wanted to exercise, I wouldn't be playing a video game, right? So like, as a gaming thing, you could certainly make the argument that it failed. I mean, they stopped making it, right? Like, and there's no games for it. So like, it definitely failed as a gaming thing, but because like the economies of scale and the need for it to be cheap and accessible, it got this whole other second life for people who really, really, really wanted it, like, and they couldn't get this kind of technology otherwise, So it is kind of fascinating how something could be a commercial failure for its intended purpose, and then take on this whole second life that's arguably like far more important than what the thing was originally made for. I remember seeing somebody on Reddit or whatever, they said they were getting an MRI or something like that, and they looked up at the machine and there was an Xbox Kinect looking down at it. But it had the Xbox logo on it and everything. Medical machine, I'm sure costs, 6 figures. And it just as an off-the-shelf gaming piece of hardware, to start from being like a dancing game accessory and ending your run inside of medical equipment and potentially saving lives is a pretty cool legacy. And I guess that's what's kept them from killing it entirely, right? Because it has had this unexpected second life that I don't even think Microsoft could predict.
Roger Cheng wrote up a great obit for the old school Kinect in 2020. I'll throw the link in the show notes. It says basically exactly what you said. It's a really great article. But the technology there was really cool back in the day. And I remember we were tying these things to Roombas and using them as 3D mapping, robots back when doing simultaneous location and mapping was really hard back in the 20 noughts even. Anyway, really fun stuff, and it made it entirely accessible to hacker spaces and normal people, and I think that's really pretty cool. I also remember the first time we looked at it through something that could see infrared, and you see this odd, irregular pattern of dots being projected out of it. And that's the structured light thing that the old school Kinect used to use. It has a fixed pattern of these dots, and when they're shifted off of their location, when viewed from the camera, which is off to the side, they know that there's kind of this triangulation parallax thing going on there, and they can figure out where all the points are. And that's how that one worked. Again, this new one, the Kinect 2 or whatever, the Xbox Kinect, the Azure Kinect, the super expensive one, unfortunately, uses time of flight sensors and is just bonkers. And if you need one of these, you probably already know it. But I'll also throw in a link to a neat academic paper comparing the structured light Kinect, the Kinect number 1, with this modern Kinect number 2, which is now unfortunately discontinued, but you can still get the sensors. And that's a neat paper too. Even if you just want to understand how they both do distance sensing, it's really, really cool. But if you actually have an application that needs one of these, it kind of talks about the pros and cons. Anyway, really, really cool tech. Sorry to see it go. I mean, it was out of my price range anyway, but reminded me of the old Kinect and how much the technology in 3D ranging cameras has come in the past 15 years is pretty amazing.
All right, I have to admit, I picked this one because I really like seeing people make stuff out of toaster ovens. I don't know why, but it doesn't come up as often as I would like. And so when I saw a new one this week, I had to pick it. This is, of course, not for making toast. It's for soldering your PCBs, and this is not a new thing. We've seen a lot of these, and there's an argument to be made that you could just put a PCB in a regular toaster oven and not do any kind of modifications to it, and it would sort of work, and you could just be, move on with your day. Or you could tear the toaster oven apart and rebuild it entirely and make custom electronics for it and upgrade it and add, powered exhaust to bring the temperature down so you can, more accurately get that cool down curve. And you could turn the toaster oven into its own project. And that's what we like to see on Hackaday. If somebody had just... that's probably a lie. I'm sure if you will go back far enough, we probably did write about somebody who literally just put a PCB in a toaster oven and said, "Hey, that worked." But you only get that once. Like, that was just the first time. Like, from now on, you have to do a lot more work and you have to take it apart. And that's what this is. And we've seen some cool ones. This is up there, certainly. What I liked particularly here is, I went through several phases. At one point there was a Raspberry Pi powering it. And then, those became like gold. So that was, moved on to another project. And in its place went an ESP32, so that involved a considerable retooling of how the software worked. The original electronics, have been replaced with custom PCB, which, hey, if you happen to have the same toaster oven, which I'm not familiar with the brand, Breville, that's great because you could just drop these new boards in there. I think probably the big standout feature is, like I said, there's this giant powered exhaust fan on the back, which off the top of my head, I don't know if we've seen in other ones. Usually they beep and it says, open the door, and that's how it cools down. But that's, who wants to open the door with their hand? That's like, that's some baby stuff. This actually has, this big, it looks like it went into the big box home improvement store and just said, where are your heating and air conditioning ductwork, right? Like, it's definitely a heating duct coming out of the back of this toaster oven, complete with a powered shutter so that when it's hot, the exhaust is closed and it stays warm, and then that opens up. So, this is really, really well thought out, like so that you can control the temperature. You don't need this. Probably no one needs this, but you want it, and that's really what it's all about. Like, making something that could have been easy far more complex and having a lot of fun while you do it.
This actually looks in spirit a lot like my coffee roaster. I hope this thing doesn't catch on fire anytime soon. Because he's going to be pulling the fan and it's going to be like trying to cool it down, and he's just going to have the same thing I did. I'm scarred. I'm scarred.
Well, that's a good way to bookend this. Like, we talked about, a homebrew heating device potentially burning someone's house down, and now we're going to tell you how to make your own.
No, it's a super hack. And it is true that that's like usually the weak part of these reflow ovens is the cool down part. And, you can see that he's done some insulation here to make it so it heats up fast enough. But then having a little fan on the back to cool it down is pretty sweet. So it's a servo motor and an extension arm so nothing melts. And then, a bunch of stuff glued together with whatever that is, some kind of thermal compound.
The red stuff, yeah.
Yeah, what is the red stuff?
I imagine some kind of furnace cement.
I need me some red stuff.
Probably got that in the same aisle where the heating vent came from.
Yeah,
right? You got something
I
can seal this with so I don't burn my house down.
All right, my first quick hack comes from Randomona. This is kitchen steganography with turmeric. Basically, this is the old school, like, invisible ink trick. Turmeric is a pH indicator, and so she makes a wash of this and writes with an invisible baking soda ink. Where you wrote with baking soda turns red, and the rest of it turns yellow. The coolest gimmick here, though, is that she's also drawing in yellow ink over it. And so when you hit it with the turmeric, the yellow part fades out and the red part fades in. Just a sweet effect. Next up, explore FFmpeg from the comfort of your browser. Sam Levine whipped this project together. It is like one of those, what do they even call them? It's one of those like flow-based programming things like GNU Radio where you drag the blocks around to do FFmpeg filters, which have just a horrible syntax. And making a complex flow graph of those is very, very simplifying. I couldn't get his online app to render the FFmpeg videos for me, but it gives you the command line you'd need to do it with anyway, which is basically the whole point. So total success there. And last up, Card.io is a credit card shaped open source ECG monitor by Daniel Buga. This is just a really sweet little demo of what you could do these days with nice cardiogram chips. It's also got the patches where you put your thumbs, do double duty as the cap sensors for the menuing system. Just a sweet little credit card. I have a soft spot for these like credit card projects, and this is one of them that aims pretty high. Little OLED screen shows you a real-time ECG. People in the comments debate about whether it's medically acceptable. It's clearly not, folks. It's, a hacker project, but it looks like it does the job.
So my first quick hack is checking belt tension gets easier for some Prusa 3D printers, and this is a write-up about a pretty cool trick that Prusa has added in the assembly manual, but also into like their maintenance for the new Mark IV and the XL printers. If you want to figure out how tight the belts are, you just kind of flick them, and they should make a drumish kind of guitar sound, like a deep bass note. What is that? I'm not terribly musically inclined, right? So I might need some technical assistance. So they've come up with a web app that you can load on your phone, and then you hold the phone next to the belt, and you flick it, and it will show you on there, the sweet spot. And it's a really cool idea. Next up is this CRT luggable makes sense. I saw some comments last episode of the podcast. People said there's too many cyberdecks. Well, deal with it. Here's another one. But this at least is different. It's different. This isn't a Raspberry Pi in a box, right? It's still a box. But it's a wooden box, which is unique, and it has a proper computer inside, AMD Ryzen with 32 gigs of RAM. But you wouldn't know it to look at it, because externally, it looks like a pile of trash. And I mean that in the best possible way, because there is a school of thought that a cyberdeck should look like you built it out of trash. And in that case, this is absolutely par for the course, including the green tiny CRT that was apparently pulled from an old CNC machine. It looks phenomenal if you want it to look like it was built in a post-apocalyptic hellscape. And it actually has some power that brings to the table, which is a nice change of pace from the usual, Raspberry Pi inside of a 3D printed frame. So even if you are not on board with the cyberdeck movement, I think this one's got to at least win some points, if nothing else for the video of the Matrix screensaver running on a proper green CRT. And last up, take a peek at this 3D printer. This is from Al Williams, wordplay as always. And the peak here is PEEK. It is a 3D printing filament that stands for something, I'm sure. And it's usually referred to as like an engineering plastic. They use it in kind of aerospace stuff. It's sort of like Delrin, I think, but very strong, and traditionally not something you can print on a 3D printer, only because it needs to be printed at ridiculously high temperatures that no normal printer could hit. But if you modify your machine to hit, extrusion temperatures, better than 400 degrees Celsius, the interesting thing with this machine is that, we've actually covered printers being modified for peak before. There's even, I wrote an article, NASA modified, I think, a Lulzbot a few years ago. They generally have a heated chamber because the chamber needs to be super hot too. In this case, ND3D is actually using a halogen heating element in what looks suspiciously like a pie tin, but I'm not sure if it is or not. And it just has such a concentrated heat on the printed object that it's able to do it without the enclosure. This is probably the most DIY approachable printer for doing peak that we've seen thus far. supposed to only cost a couple $100 for the parts and everything. Probably not something the average person is worried about printing in aerospace materials, but it is a cool milestone to see how far we've come in 3D printing. That all the normie plastics, they're easy enough. Now we're branching off into the aerospace stuff because we got to find the next frontier.
It's time for Can't Miss Articles. These are long-form pieces written by our lovely Hackaday writing staff. And this week, I picked the loveliest of all, Tom Nardi's review of the Wayne Lux K8, a diode laser that's ready to work. You've been offered a bunch of trash, and the good news is you've turned most of it down. This one you thought was plausible enough that you actually took it. And, honestly, what do you say? Would you say you've been enjoying using this thing?
Yes. More so than I thought, frankly.
Yeah.
Cool. I do mention in the review the software is, the pack-in software with a lot of this stuff. I think that they must have felt like, hey, we're contractually obligated to offer some kind of software, but
right.
So there is software in name, and we'll leave it at that. Like, there's no reason to install it on your computer, but the hardware is great.
Yeah, and that's what you point out in your review is that it's one of these blue lasers on a gantry laser cutters / I guess we should call it a laser engraver because that's what they sell it as. But you can cut light wood with it, right? So, if you don't mind crispy charred edges, you can cut light wood with it.
Yeah, I did wood, acrylic, dark color acrylics, obviously. Right. I didn't even, honestly, the promotional material says you can go as high as like 8mm plywood, and I never even pushed past 5.
Right.
I think it is important to remember being a diode, it is limited compared to, a CO2 tube laser, which would, rip through this stuff in seconds.
Yeah.
So like even for the 5mm plywood, it takes, a few passes. At 4 passes, you could pop it out. At like 5, it falls out, but the kind of thing that struck me, ironically, I don't think I ever put it in the review, is that, coming from a 3D printer, which is what I usually use, where everything takes hours to make,
right?
Like this seemed like a rocket ship to me, so like it taken, 4 passes to cut a piece of plywood. Okay, the whole job is like a 4-minute cut job or whatever. Like, to me, that was amazing. Like 4 minutes, like the 3D printer doesn't even warm up in 4 minutes, right? Like I'm still waiting for the extruder to get the temperature. So, if you've got a K40 or something like that, you're looking at this and you're probably laughing, but it's still totally viable. Maybe I'm more patient than some, but to me, it's not a huge deal to wait 3 minutes instead of 45 seconds. If it's got to go around a couple times, and I was impressed. I have like a little gallery of stuff that I made on there. There's a little control panel I did, which I thought was. We mentioned that earlier. Like, that's always something that I always think, like, how can we make cool looking control panels? And that one was made out of acrylic. I added like white paint to make the letters pop, and so I think there's if you have patience, if you're not looking for a rocket ship and you're not looking to cut through like really thick stuff, you can get away with one of these diode lasers. And like you said earlier, the difference with this one was it's fully enclosed. It turns off when you open the door. You can't do the refrigerator thing. Like, does the light go off when it,
right.
As soon as you open the door, it does cut off. It has its own ventilation, and it was just kind of like the first one that I had come across that seemed like it was sanely developed.
Right.
Everything was there for you. And don't get me wrong, you pay for it. It's more expensive than these open lasers that are out there, but I feel like if you're going to do it, you got to at least have the ventilation. Some of this stuff makes a lot of smoke and stinks. So,
yeah.
Even if you're not scared of laser, and you should be. You should definitely be scared of laser, by the way.
Yeah.
But even if you're not scared of the laser, you at least have to appreciate that it's enclosed and has its own ventilation fan, and can shoot it out the window or into its little air cleaner sidecar. So
absolutely, the trade-off for that is that the working volume is pretty small, right? Like
Yeah.
volume, the working space, the surface area is what? How big was it?
130 millimeters
Yeah.
square,
So,
so 5 inches or whatever.
yeah, it's 5 by 5, 6 by 6, something like that. That's not so bad. I mean,
It's not bad. I think they probably sized it to like put a phone or something in
Yeah,
there, because that's one of the things
exactly.
they show on the Kickstarter is like doing phone cases. And I should say, like, the 5 by 5 is the area that the laser can reach. But you could put a bigger thing in there, I think, maybe something like the size of probably like a small tablet would fit inside of it, and then like you'd be able to hit that 5 by 5 center part of it. So you could,
Right.
if you
Okay.
had something bigger that you wanted to put in there, but you can't open the door. Like I said, if you open the door, it shuts off, so you can't have something hanging out for good
Right.
reason.
Yeah, right. Exactly.
Like if you thought like, oh, okay, I'll just have the door open and this hanging out. It won't let you do that. It'll just prevent the job from starting.
Yeah.
And also, I was very impressed. I don't know if I mentioned that either. I should mention these things in the review. For a while, I was concerned that if I open the door, it's like the Prusa's got the stop button, right? Like when you're printing, you can hit the stop button, but then like your print's beat because like you stopped. And I wasn't sure, like, if I opened the door, was it going to just, like, shut down and lose its track of its position? But it actually doesn't. If you open it, it just kind of pauses the processing of the Gerbil commands, which I'm not really sure how that works, because the software, I'd imagine, is still sending it. I guess there must be some kind of M response that says, hey, wait a minute, stop sending me commands or something. But whatever it is, it works. So when you open the door, like, Lightburn knew that it stopped, and it said, okay, wait, we're holding on. And then when you closed it, it would continue from where it left off. So
Yeah, Gerbil acknowledges every G-code command with an OK. And so your sender just has to, stop sending when it doesn't get an OK back. And everything will work out fine.
It was like I said, an impressive experience, and I'm kind of inspired to find more stuff we can do with these lasers. So I do think that going forward, we might, we talked about this before. We have like the 3D printing, articles where like, different tips and tricks for 3D printing. I'd like to maybe do something like that for lasers and because it's a new, 3D printers are getting a little too mainstream, right? Like everybody's got them. And I think, most people know how to use them, but, the CNCs and lasers are sort of like the next step. Like that's the next thing people are drooling over, as we saw with, piecing together that CNC earlier. Like people are willing to work to get these things. So I think that might be cool to start, looking at different software that's out there, different techniques and that sort of thing. So, if you've been holding off on buying a laser, I think this is kind of the shape of things to come, which is very exciting. More capable and more safely designed than what has previously been out there.
Yeah, I think if you need a turnkey solution, then something like this makes a whole ton of sense. Part of me says, you slap a box and some fans on one of those open frame ones and you're most of the way there. But I've actually done that with my CNC machine. I actually strapped a, whatever it was, quote, 6-watt, but probably 2-watt laser head on there and did some of this. And it makes a ton of smoke. And so I had to build a vent hood for it. And then, I don't want it reflecting. So I only do it in the basement with the door closed. And, and even then I built a shroud that like travels with it. And of course it ends up being a lot of work. So, I see the price thing, but if you had to put down your own $600 for this.
Oof, put me on the spot, huh? I will put it this way. I have been looking at getting a bigger laser.
Yeah.
Like I really liked using it. It's very powerful. Relatively speaking. But, I already kind of am seeing like, well, this is cool, but I'd like to do bigger things. So I am now looking, I'm kind of going reverse. Now I'm looking, like you're saying, at one of the other lasers and then building an enclosure for it. So,
$600 gets you a K40 and $150 in your pocket to work on some improvements for it,
Yeah, oh well, you will be working on
which you got to do. Yeah, totally.
Right.
But totally. But again, you gut the internals, you put an Arduino in there to run the controls, and that solves the software firmware side of things. And then you put some switches on the doors so it shuts off. You get some better cooling, you get a better fan and some air assist. Okay, it's work.
I would say, and I kind of put this at the end, like if you have limited space, if you're in an apartment or something and you can't do like a laser area, it's worth it. It's worth it to have it turnkey. Have like the cool thing with this, especially even like compared to like the K40, because I looked at that too, in the past. And you got to do like the water cooling and stuff. Like,
K40 needs space in your basement.
Yeah, like I could literally put this thing up on the shelf and then like in a month be like, oh, I got to laser something. Bring it down, plug it in, laser it, and then put it back on the shelf. And that would have like no more thought than that. So if that's a benefit to you, set it up real fast, cut something, put it away. To my knowledge, really nothing else out there at this price point. So
yeah, that's the benefit to neat and tidy. Yeah, I hear you.
That's probably going to be what it's going to be now that one of these companies has put out one of these ones in a box. Everybody else is like, oh, okay, I got to do one in a box too. And then we're going to see Amazon's going to have a whole bunch of lasers in a box in a year or two, and that'll be to the benefit of everyone.
Yeah, everybody with eyes out there.
Yeah, right. Everyone with eyes will have ones in boxes. I don't think we can complain about that. Well, my pick for a can't miss article is Retro Gadgets, the 1974 breadboard project. This is from Al Williams, and it is specifically a look at a variant of the traditional breadboard, the 1974 Slip and Clip, which I just love the name of. And this was proposed in magazine Elementary Electronics, and that's interesting enough. In the 70s they were trying to kind of come up with different breadboards because the standard breadboard, as we understand it, did not yet exist. But what I really liked about this is that Al, as kind of part of that discussion, also goes into, the history of the breadboard proper. What is a breadboard? Why is it called that? How did we get to this? The current breadboard that's so common, Al mentions in the article, probably if you're reading this, you have one within arm's reach, and I do, and I'm pretty sure Elliot does, and I'll wager to bet, unless you're in your car listening to this, you probably also have one nearby. So it's really cool. It's something that we take for granted, but it didn't always exist, and it's one of these kind of like transformative things that has made electronics way easier than it used to be. I'll admit I knew the breadboard name came from literally a wooden bread cutting board. Like I knew that much, but I'd never seen one before until this article. And in my head, and this might be like naive of me, for some reason I thought that they would take the cutting board, and now we're talking like back in the day. This is like the 50s and 60s. I thought they would take the cutting board and like drill holes in it, put the legs of the components through it, and then wire wrap it on the back.
Oh,
I thought that's how the breadboard with the holes came to be. But that's not actually what they did. They literally just used nails, and then they wire wrapped between the nails on the surface, and it's kind of cool because you can just wherever you want a connection, you just drop a nail, right?
Yeah.
So I always had this idea, like somebody like meticulously drilling these little holes in a breadboard and running leads through it, and that's not exactly the case. But it is a legitimate piece of wood, and it did let you wire stuff up. Honestly, if it wasn't for the fact that the components we use today are far smaller than any nail you could reasonably handle, it's actually not a terrible idea. Like, I'm looking at it, I'm like, yeah, I can kind of see that. Like, you just wrap it around there, boom, drop a nail. Oh, I got to make a connection here, boom, another nail. It was cool to actually see that. And he has a video here linked from Make, actually. They did like a modern, like a reenactment. We're going to reenact using a breadboard like back in the day. Like I said, from there he goes into talking about some of the other ideas, before the concept of the modern breadboard was developed, and this one specifically they're talking about was there was holes in the board, huh? So it wasn't completely unrealistic to put holes in the board. And each hole in the board had like a little copper pipe, and there was paper clips on each side and a rubber band run through the pipe. So if you can kind of visualize it in your head, if you pull the paper clip up, the rubber band would want to pull it back down so that you'd clip your wire or your component inside of that little, sandwich. So a lot of paper clips, and a lot of rubber bands would be required for it. But I appreciate creativity. And I guess at the time it must have been like, wow, I don't have to drive any nails. I could just use rubber bands. This is great.
I love this old school breadboarding with the like nails because it's so similar to wire wrapping, which they were doing at the time. You could see how the idea came about. It's wire wrapping, except you're doing it with the component leads around nails rather than, with wire wrap wire around posts. But then it also strikes me how similar that is to the kind of Manhattan/island prototyping style that a lot of radio amateurs do. My favorite version of this is where you keep one piece of copper intact as the ground plane, and then you cut out a bunch of little circles of PCB and you glue them down, and then you can solder to those to make your connections. So you have all these kind of islands of PCB material, round PCB material that then you can solder to. And that's serving exactly the same role as the nails in this breadboard. I mean, with the island one, you get a nice ground plane and you get all sorts of kind of radio frequency benefits, but you have to solder, right? So there's a trade-off there. The Colin Cunningham video that he linked to is an absolute classic. I actually remember watching that when that came out. It's just so deadpan, and he's like wrapping things around nails. That's so awesome.
You have a point there I didn't really consider. Like, it's interesting that the old school breadboard was much closer to how the electronics would actually be manufactured.
Yeah.
Than like the modern breadboard, right? Because like you said, like this is basically how they would have wire wrapped it, except there's a piece of wood and it's kind of like freeform, and whereas like there's really no analog to current breadboards to how we do PCBs. You know what I mean? Like it's not really the same. It's convenient and it lets you tack stuff together and it's cool, but like it really doesn't resemble the final product in any way because the mechanism by which it operates is totally different. The internal connections and the little internal grippy stuff. It really went from like this is almost like practicing how you're going to build the thing to the modern breadboarding, which is much more theoretical, and then you use a totally different technology.
Yeah, then you just have to draw the schematic somehow from that mess on your breadboard.
So it's interesting that like the prototyping has gotten farther from the manufacturing than it was previously. If you think about it in that way.
All right, that wraps it up for this week's Hackaday podcast. Thanks for listening. To follow the links or leave comments, head over to hackaday.com/podcast. And if you see anything cool or do anything cool, shoot us an email, tips@hackaday.com. And until next week,
keep on hacking.
I don't trust any of these damn phones anymore.
It's another way for the government to listen to us. If the government wants to listen, they have to subscribe like everybody else. Little did I know you were going to set fire to your kitchen and make it particularly timely.
My sweatshirt still smells a little bit like a campfire. Kitchen Stegrenog. If you would like to follow the links, I do this every time. What's my problem?
We should probably stop the recording at this point anyway.
Yeah, I think we're done.